Very good evening, everyone. We are going to start the new chapter of our 10th syllabus, and which is the part of chemistry beta, acid, bases, and salt. Someone is in waiting room, Sana. Okay, acid, bases, and salt. Okay, keep replying.
Yes, sir.
Yes, sir.
Okay, so first
Yes.
we have to understand the introduction part of this chapter. Okay. So first we will understand what are acid, bases, and salt, and then we will start the chapter then. So first, acid. Okay. Have you tasted lemon juice? How it tastes?
Yes.
Sour, right? Yes. So substance which are sour to taste. Substance which are sour to taste. Okay, are called as acids. Are called as acids. Okay, but only this condition. Okay, we cannot describe the acid because we cannot test all the acids, right? Because some acid may be poisonous. Is it or not?
Yes.
So we have different method in order to identify them. Okay, so first I am going to give you one example. Suppose beta we have HCl, hydrochloric acid, and you know it is been secreted in our stomach. You know that, right?
Yes, sir.
Yes,
Hydrochloric acid. Okay. When HCl is going to dissolve in water, beta, water. When it is going to dissolve in water, it dissociates completely in order to form H positive ion and chlorine negative ion, right? AQ means it is aqueous, means in water. So that H positive ion is released by that substance, okay, which substances are called as beta acids. Okay, so I'm writing next definition here. Substance, okay, substance when dissolve in water, dissolve in water, gives H positive ion. Okay, H positive ion are called as acids. Or you can say acids when dissolve in water, they produce H positive ion. Okay, are called as acids also. Understood? Now, one more thing, very important, we are going to discuss here. Very interesting one also. Okay, see, we know hydrogen atom have atomic number 1 and atomic mass is also 1, right? Everyone?
Yes, sir.
Are you?
Yes.
So yes.
Yes, sir.
That means hydrogen have 1 proton in its nucleus and 1 electron in its orbital, right? Like this. Is it or not?
Yes, sir.
Yes. And suppose when hydrogen is going to lose that electron beta. Okay, like this. Okay, here we have hydrogen. When it is going to lose electron, so hydrogen will form H positive ion, right? Is it?
Yes, sir.
So at that state, that electron is being lost. So or means at H positive state, only proton is present in nucleus of an atom. Only proton. Right?
Yes, sir.
Yes. So when hydrogen atom loses electron and produces H positive ion, at that state, hydrogen positive ion contain only proton in its nucleus. No neutron, no electron, nothing, right? Hence, that's why hydrogen positive ion is also considered as proton. Therefore, H positive ion or ion is considered as proton beta. Easy?
Yes, sir.
Yes. That's why when they dissolve in water, they produces H positive ion. So can we say that produces proton? Can we say that?
Yes, sir.
Yes. That's why acids are called as proton donor. Acids are also called as proton donor. So I'm writing here when acids. Let me make another point here. Wait. When, very important point. I'm writing here note. When acids dissolve in water, when acid dissolve in water produces H positive ion, which is considered as proton. And you know the reason, because at H positive ion only proton is present in its nucleus. Hence H positive ion, okay, is called as proton. Therefore, acids are considered as proton donor. Considered as proton donor. Proton donor. Understood, everyone?
Yes, sir.
Yeah. So now you have the reason why acids are called as proton donor, because when they dissolve in water, they produces H positive ion, and H positive ion is nothing but proton. That's why acids, when they dissolve in water, they produces proton. Hence, they are also called as proton donor. Easy?
Yes, sir.
Okay.
Yes.
Now, third point. Okay, first point, here we have covered for substance which are sour to taste. Second, they are produced as H positive ion. Okay, and this is the part of the third only. They are considered as proton, so they are proton donor. Okay, next, third point. See, litmus test. You know litmus paper, right?
Yes, sir.
Okay, so when acids, or we can directly write turns acid turns blue litmus paper to red. Okay, so for that test you just do remember ABR. What is ABR? Acid turns blue litmus paper to red, like this. Acid turns blue litmus to red. And for bases it is just opposite. BRB. What is BRB? Bases turns red litmus to blue. Easy?
Yes, sir.
Yes. So this is the, like you can say, identification test for whether the given substances are acid or not. So we can dip the acid in aqueous solution. If it turns, or any compound which is given in a sample here. Okay, suppose here we have like two sample here. Okay, A, and here we have B. Okay, they are the two sample, but we don't know which one is acid and which one is base. If suppose we have like dipped blue litmus paper here, if it turns red, then that one is acid. Okay, so without testing, okay, without dissolving in water, okay, we can identify whether the given substance are acid or base with the help of litmus test. Easy litmus paper test.
Yes, sir.
Yes.
Yes,
So
sir.
acids are the substance. Okay, when they like tested by litmus paper, they turns blue litmus paper to red. If they turn blue litmus to red, that means they are acid. Okay. Next, fourth point about the acid. Any idea about next point? Fourth point. What it may be?
So the pH level is less than
Yes, yes, very good. pH level. Okay. So we have a pH scale. So pH scale I am going to draw over here. It is marked here 0 to 14. And here we have center over here, center value 7. And it is been marked like this. And from this side also. Like this. Okay. So see that 7 pH value is for neutral beta, neutral substance. Okay. If pH value is less than 7, means in this side, 7 less than 7 up to 0 beta. Okay, then they are acids. And if pH value is more than 7 in this side, okay, then they are bases. Okay, so can we say the substance having pH value less than 7 are called as acids? Easy?
Yes, sir.
Yes. So let me write here substance having pH value. pH is potence of hydrogen beta. Potence of hydrogen. Sometimes people used to call percentage of hydrogen also, but actually it is potence of hydrogen. Okay, substance having pH value less than 7. Less than 7 are called as acids. Okay, so these are the 4, like you can say test or maybe characteristic features of acids. Okay, everyone. Now we will understand few examples. We have to go through with example also. First, we as discussed already, HCl, hydrochloric acid. Hydrochloric acid. We have HBr, hydrobromic acid. Hydrobromic acid. And we have H2SO4, sulfuric acid. Then we have HNO3, nitric acid. Nitric acid. We have CH3COOH, acetic acid. You know vinegar, right? Vinegar.
Yes, sir.
Yes. Are you enjoying sometime Chinese food?
Yes.
Yes. So in Chinese food they don't use to like add a tomato in order to provide the flavor test. So they are using vinegar only. So 4 to 8% aqueous solution. Aqueous solution of acetic acid. It's called as vinegar. Okay. Okay, everyone.
Yes, sir.
Okay. So these are the important acids that we are going to discuss. We have one more, phosphoric acid. Phosphoric acid. Phosphoric acid generally phosphorus. It is been in your syllabus or not? Probably it is not there, but we can write. It is H3PO4. It is phosphoric acid, beta. Phosphoric acid. So in your syllabus, we have HCl, H2SO4, HNO3, and CH3COH. These are the extras that you can just to remember. Okay.
So what about citric acid?
See, they are very complex organic acid, beta. Very, very, very complex. Okay.
Okay, sir.
Yes. Okay, so I want just take a screenshot, everyone.
So even formic acid also comes in.
Yeah, formic acid is like very, very simple. It is CH3COOH. Here instead of CH, we just use HCOOH. That's all. It is formic acid.
CH2O2, sir. CH2O2.
Yeah, but its representation is like this, like H, C, double bond O, OH. So CH2O2, yeah, you can write also. Okay, molecular formula. So here we have HCOOH. Okay, because COOH group, that group beta is called as carboxylic acid group. Okay, so it is formic acid. We have malic acid also. Okay, you know formic acid is present on the red ant. Have you visited sometime what? Formic acid. Wait, huh? Let me think. On mango tree, you may find that red ant.
Yes, sir.
Yes. So that red ant is main source of formic acid beta. Okay, is the main source of formic acid. That
Sir,
okay, beta.
sir, can you hear my voice?
Yeah.
So my network.
So red ant contain formic acid. See, red ant contain formic acid, hence so-called formica. Okay, suppose you have took about 10 to 15 ants and just crush them, and if you will smell that, you will loss of sense for some time. Okay, because it is a kind of an anesthetic drug also, beta. You know anesthetic drug which may cause loss of sense.
Yes, sir. Yes.
Yes. Okay. So any doubt here? So we have 1, 2, 3, 4, 5, 6, 7 example of acids.
Sir,
But only, beta,
what's H2CO3?
H2CO3 carbonic acid.
Okay.
Okay, let's write one more time. H2CO3. H2CO3. It is carbonic acid. Carbonic acid. See what happens generally when carbon dioxide gas pressurized at a very high pressure and low temperature with water. Okay, they combines to form H2CO3. So that H2CO3 in water is called as carbonated water. Carbonated water. You know Sprite, Coca-Cola, Pepsi. You know, na? Soda.
Yes, sir.
They all are nothing but carbonated water. Beta. This H2CO3 only.
Okay.
Okay.
Yes.
That's why when you used to open the cork of the bottle, the gas which is releases, okay, which is nothing but the carbon dioxide. Okay, so that soda is formed by dissolving carbon dioxide at a very high pressure and low temperature with water. Okay. Now I want you have to take a screenshot for all one by one. Yeah, here beta. First screenshot just take. Done.
Done.
Okay. Second from here. Wait. Yeah, second from here.
Yes, sir. Done, sir.
Okay. Then wait. And here. Done.
Yes, sir.
Okay. So repeat it once. Now we will start. Then basis. Just repeat it once, beta. In 2 minutes. I'll have water. Huh? Wait. Okay. So now we are going to discuss about the basis beta. So we know substance which are bitter to taste are called as bases. So I'm just converting here bases. Easy or very easy?
Yes, sir. Both, sir.
Okay. Now, if we will dissolve in water, so what will happen? We have to check first. So I'm just taking sodium hydroxide, NaOH. Okay. We are going to dissolve in water. Okay. So it is going to produce sodium positive ion. Okay. And OH negative ion beta. Okay. So that OH negative ion is a characteristic feature of the bases. Means when bases are dissolved in water, they produces hydroxide ion. It is named as hydroxide ion. Hydroxide ion. Okay. Next, substance when dissolved in water. So I'm just writing about that example. When substance when dissolved in water, okay, gives OH negative ion beta, not H positive. Now we have to convert that into OH negative. OH negative ion. So they are bases. Easy?
Yes, sir.
Okay. Then and they are proton acceptor beta. They used to accept the proton. So they are proton acceptor. So I'm writing here bases are proton acceptor. Like see acid used to produce H positive one, right? And OH used to accept that in order to form water. Okay, so that's why bases are called as proton acceptor. Okay. Then next, after that we have note when basis. Now instead of no, that proton thing is not here for basis. So I'm just erasing that extra part. Okay. So when basis gets neutralized with acid, they accept proton. Proton means H positive ion beta. Hence bases are called as proton acceptor. Okay. Next. Now litmus test. We have already gone through here that one. Okay. So bases turn red litmus paper to blue. Okay, very simple. Is it everyone? So basis
Yes.
turns red litmus to blue. Okay. Then for pH value, it is again very easy. Substance having pH value more than 7 beta. So instead of less, we have more than 7. More than 7 are called as bases. Okay, so these are the bases. Okay, now example. So let me erase that extra things for acid. Okay, so here we have bases. Okay, so first we have sodium hydroxide, NaOH. Then we have KOH, potassium hydroxide. Then we have NH4OH, ammonium hydroxide. NH4OH. Then we have MgOH twice. It is also called as milk of magnesia or magnesium hydroxide. Magnesium
Yes.
hydroxide. And another name we have milk of magnesia. So I'm writing here extra name, milk of magnesia. Then next we have CaOH twice, calcium hydroxide. And it is called as lime water beta. It is called as what? Lime water. Okay, everyone. So these are the example of bases. Everyone, take us. Okay, wait. Okay, now take screenshot again one by one from here. Done. First page.
Yes, sir.
Yes, sir.
Then from here. Wait, no? Yeah.
Sir,
Beta?
but lime water doesn't taste bitter, no, sir.
Beta?
Lime water doesn't taste bitter, sir.
Because its concentration is very less, beta. Whenever we used to prepare lime water, no, its concentration is very less.
So it's a weak base.
Yeah. Okay, done, beta. Everyone.
Yes, sir.
Yes,
Okay.
sir.
So repeated acid and base, and let me know if any doubt you have. In 4 minutes, I am having another class. Just repeat it once quickly. I hope you found the chapter like lesson interesting.
Yes, sir.
Yes.
So will you send the notes of this?
That notes, yes, beta. I will send.
The PDF notes.
Yeah. Tomorrow morning, beta.
Okay, sir.
Tomorrow morning. Yeah.
Okay, sir.
Sir, can you even send physics PDF also?
We kept it beta light one.
Yeah, sir.
I think I already sent, but I'll send tomorrow again one more time. Don't worry.
Okay, sir.
Yeah. Okay. So once you finish the repetition, if you have doubt, we can solve that. Otherwise, we'll leave the class for today. Okay.
Yes, sir.
Yeah.
So we can leave right so then.
Amita?
So we can leave, right?
Yes, beta. I'm having another
Okay.
class. Yeah.
Okay, sir.
Yes, sir. Thank you, sir.
Yeah. Thank you.
Thank you, Sabha.
Yeah, beta. Bye.